Okay, today we're going to do a lesson on factoring trinomials so that there is something other than 1 in front of the x squared term. And again, a trinomial has 3 parts or 3 terms, typically a square, and then an x, and then a constant which has no variable in it. And the x here could be x or y or a or b or whatever, just whatever variable, as long as it's in the form of a square term, a square variable, and then a variable, and then a constant. So you really need to be patient during this process because it is sort of a trial and error type process. There's not really a shortcut per se where you can do it faster. But if you look at the example here, basically what happens is, see how there's a number in front of the x squared? So you can't just factor it the way you could if there was just a 1 there. So one of the methods that we're going to talk about today, or the main method we're going to talk about today, it's not the only method, is called the AC method. And so what you're going to do is multiply the coefficient that's in front of the square term times the constant. Okay, now you're going to get a number. So in this case, you multiplied 6 times 12 and you got 72. Now we need to find all the factors of 72. Again, so 1 and 72, 2 and 36, 3 and 24. You might not know these, and so you're welcome to put it in your calculator. So you would take the number and divide it by 2, divide it by 3, divide it by 4, divide it by 5. When you divide it by a number that doesn't go in evenly, you'll get a decimal as an answer in your calculator. So just ignore those. So we're looking for integer factors. In other words, whole numbers that will go into that. So once you do that, so here are the steps basically. I kind of got ahead. The first thing you do is you factor out any greatest common factor. So you want to simplify this trinomial if you can. So if it can all be divided by 2 or 3 or 4 or 5 or something like that, or 10, you want to actually be factoring the simplest trinomial that you can. So factor out that greatest common factor, but don't throw it away. You need to keep it. Also, you're going to multiply the leading coefficient a, that's like in this case it's 6, times the constant c. That's why it's called the AC method. So you find the factors of AC, a times c, so 6 times 12. You're trying to find the factors of those so that the sum of the factors, like 1 plus 72 or 2 plus 36 or 3 plus 24 or whatever, is actual, the sum is actually b. This should say b. Okay? So you're looking for 1 plus 72 to be 17, or 4 plus 18 to be 17, or 6 plus 12 to be 17. And in this case, 8 times 9 is 72, but 8 plus 9 is 17. So you're looking for it to add up to b. Then you're going to rewrite the middle term so that you either are sum or difference, because sometimes there's positives and negatives here, so that the sum of these is written separately. Now, I haven't changed the value of this trinomial when I changed the middle term from 17x to 8x and 9x. 8x plus 9x is 17x. So I haven't changed the value of the trinomial. I've just divided it into a polynomial with 4 terms. Now, what's the point of that? The point of that is that at that point, whenever you divide that bx into 2 separate terms, you can now factor by grouping. Remember, factoring by grouping means that you're going to take whatever's in common with the first 2 terms and whatever's in common with the second 2 terms and divide it by that, and then you can get your factor. So remember, factoring is just the inverse of FOIL or distribution or any kind of multiplication. So what we're trying to do here when we factor this is break it into its smaller parts that you started with. Okay, so then after you do that, you factor by grouping, then you check your answer by using either distribution or FOIL. All right, so let's go through a couple of examples. So we're looking for the greatest common factor here. I notice that all of these terms can be divided by 3. Okay, so then that means, all right, so now I only need to factor this trinomial, which is a lot simpler than factoring the original trinomial. Okay, so here's my a and here's my c. So 2 times negative 6 is negative 12. So I want to find the factors of negative 12. But the factors of negative 12, remember, negative 1 and positive 12 is different than positive 1 and negative 12. The reason is, even though you multiply these numbers and get negative 12, but when you add them, remember, we're looking for the sum to be b, okay? So when I add negative 1 and 12, I actually get positive 11. But if I add 1 and negative 12, I get negative 11. And that's a different b term. So we're looking for something that will multiply to give multiply to give negative 12, but add up to give negative 1. There's an imaginary 1 here. So negative 2 and 6 is 4, and this is negative 4. So we're getting closer to negative 1. So negative 3 and 4 is 1, and 3 and negative 4 is negative 1. Now, once you find what you're looking for, you don't need to keep going to try to find other factors. You go ahead and just keep the ones that work, okay? So now I can rewrite this trinomial as a 2x squared plus 3x minus 4x minus 6. Now, what did I do? I replaced the negative x with 3x minus 4x. These two middle terms are the same. The first term never changed and the last term never changed. I'm only rewriting the middle term so that I can factor by grouping. All right, now it doesn't really matter if you had put the negative 4x over here and the positive 3x over here. You would still factor by grouping and you would get the same answer. It would be a little bit different process. In other words, it'd be in the different order, but you would get the same answer. So that part doesn't really matter. Don't stress too much about that. Okay, so I still have my 3 out here. I'm going to start with brackets because I'm going to be using parentheses. So both of these terms can have an x in common, so I'm going to factor out an x. Okay, and then I'm going to look at these two terms. Now, since this first term is negative, I'm going to factor out a negative number or negative variable, depending on whatever's in common. So in this case, it's a 2. So then negative 2 times positive 2x will give me negative 4x. Remember, you're dividing, so that means when you multiply back out, you should get the same answer. And negative 6 divided by negative 2 is positive 3. Now, the goal here is that, remember, when you're factoring by grouping, that you get the same terms in the parentheses that you're multiplying by. So if you think of this as like saying x times a minus 2 times a, like whatever's in the parentheses, I'm just representing as a. It could be whatever. So if I could basically factor out the a from both of these terms, and I get a times x minus 2, right? So I could factor out an a from each of the terms, and I get a. So ax is going to be what I started with, and a negative 2 is going to be what I started with. So it's the same kind of concept, okay? So I'm going to factor out a 2x minus or plus 3 from both of these terms. So I get 2x plus 3, and there's an x here, and there's a minus 2. Okay? And so this is the factored form of the trinomial. Okay? And you would keep the 3 like you started with. All right, let's do another example. So we're looking for greatest common factor. There's no variables or constants that you can multiply or divide each of these terms by, so there's no greatest common factor. Now we're going to multiply a times c, and we get negative 30. 3 times negative 10 is negative 30. And we want to find the factors of negative 30 such that when you add them together, again, you get negative 1. Okay, so negative 1 and positive 30, I'm going to be getting a positive 29. So that's going to, and I'm not even going to worry about the reverse of that, because if you notice over here, all of the answers end up being the same. They just change the sign. So 29 and negative 29 are not really going to help me. So 2 and 15 is going to give me 13. Well, that's closer. 3 and 10 is going to give me, negative 3 and 10 is going to give me 7. Okay, and then 5 and 6. Ooh, I'm getting closer. Now, I have a 1, which is what I wanted, but I actually need a negative 1. So if I switch the signs, I get this. So these are the factors that I'm going to use. I'm going to replace the negative 1x with positive 5x and negative 6x, and then keep the 3x squared and the negative 10 the same. So again, I don't want to change the first term or the last term. I'm just rewriting the second term. All right, so I can divide this by x and this by negative 2. Okay, so then I get x times 3x plus 5 minus 2 times 3x plus 5. And I'm going to use the same method that I did before. I can factor 3x plus 5 out of both of them, and this is my answer. Okay, let's do a couple more problems. Sometimes when you're using this method, you get really, really large numbers, like in the hundreds or whatever, and you may not know those factors. And so when it's really, really large, use the factors of the, that you started with and kind of break them out into different possibilities. So the first thing I want to do is look and see, is there anything in common with all of these terms? And there is. The y squared can be factored out. Oops, just y. And then 7. Okay, so I can't factor out any numbers, but at least it's a little bit easier than it was before. Okay, so 15 times 7 is 105. Well, you might say, oh my gosh, I don't know what the factors of 105 are. Well, you know that 15 times 7 is equal to 105 because that's what you did. 15 can be broken down into 3 times 5, okay? So basically you have 3 factors. If you did a factor tree of 105, you have 3, 5, and 7. So I know that 5 times 7 is 35, so I could think of 3 times 35. I could think of 3 times 7 is 21, and then that leaves 5. So basically what I'm doing is I'm taking combinations of the 3 and the 5 and the 7, and I'm multiplying. So like if you looked at 3 and 35, okay, and we want it to add up to 26, okay? So that's not going to work. And 21 and 5, we know because we got the 7 and the 3 is 21 times 5. Ooh, that makes 26. So we're going to keep those. All right. So we'll keep our greatest common factor. We're going to rewrite our middle term as 2 middle terms, but we don't change the value. We go ahead and divide by 3y. Nothing divides into this, so it's just going to be 1, which you can do, or you can rearrange them if you want to. Okay, so 3y times 5y plus 7, and then plus 1 times 5y plus 7. Okay, so then we're going to rearrange that, and so you get 5y plus 7 is what's factored out times, oops, 3y plus 1. Now, if you wanted to rearrange these so that the 15 and the 5 were together and then factor that out of the 21 and the 7, that's fine. You can do that. You're going to end up getting the same answer, so that's okay. All right, last one. We're going to divide this by y squared because we know that that's in common. So we have 5y squared plus 13y plus 6. Okay, so 6 times 5 is 30. And so we want factors of 30, like 1 and 30, 2 and 15, 3 and 10, or whatever, since this is positive, that add up to 13. Well, I found one. 3 plus 10 is 13. So we're going to rewrite our middle term. Okay. Now, I see that 5 and 10 have a common, and so I'll probably just put the 10y first and then the 3y second because 3 and 6 seem to match. But I could have done it the old way. I mean, I could have used these common factors in these. It doesn't really matter, but I see that. So I'm like, oh, I'll just put these together. Okay, so 5y times y plus 2 plus 3 times y plus 3, because again, I'm dividing that by that. Okay, so then I have 5y plus 3 times y plus 2. And again, I could have written the y plus 2 first and the 5y plus 3 second. It doesn't really matter. Okay, well, good luck.